security feature that's available in Windows 7 that is considered an application whitelisting feature. For today's presentation, I'd like to introduce our two speakers. Our first speaker is Brian Posey. Brian is a 6-time Microsoft MVP who will be presenting on everything that you need to know about Windows 7 AppLocker. Today's presentation will also feature Bit9 CMO Tom Murphy, who will go through some different information about the approach that AppLocker takes and what you may or may not be missing when you're looking at your endpoint security strategy. Brian, if you're ready to begin, I can go ahead and pass you the ball.
Sounds great.
And I'll let you know when we're seeing your screen, and you can launch into full screen and begin. Looks perfect. Go ahead.
Okay, thank you. And Carolyn, I'm actually having some trouble advancing the slides.
No problem. Just click your mouse on the slide itself and reactivate it and click the down arrow.
Okay, yeah, I clicked it like 6 times before it did anything.
Sometimes WebEx has a little bit of latency before it catches up, but it looks like we're advancing now. We're seeing your About Me slide.
Okay, great. Well, thank you for coming out, everybody. Before we get started, I just want to give you a little bit of quick background information about me. I'm a freelance technical writer and an IT consultant. I've written or contributed to more than 40 books, and I've published several thousand white papers and articles for various publications. I'm a 7-time Microsoft MVP for my work with Windows Server, IIS, Exchange Server, and file system storage. Prior to going freelance, I served as a CIO for a national chain of hospitals and healthcare facilities, and I've also served as a network administrator for Fort Knox and for some of the nation's largest insurance companies. So we've got a lot to cover today, but before we get started, I want to go ahead and give you a little preview of where we're going with this. I'm going to start out by giving you a brief introduction to the history of AppLocker, and I'm also going to talk about Microsoft's philosophy behind AppLocker, because believe it or not, understanding that philosophy plays a big role in being able to use AppLocker effectively. Then I'm going to move on to talking about some of the best practices for AppLocker deployments, and I'm going to show you how to avoid some catastrophic configuration errors and how to maintain AppLocker over the long term. Now, one last thing that I want to get out of the way before I begin is I need to clarify my purpose here. Obviously, Bit9 is sponsoring this webcast, and I just want to point out that my purpose in giving this is not to bash AppLocker for Bit9 or anybody else's benefit, but having said that, I also feel like I've got a responsibility to be honest with you, and I have to tell you that AppLocker does have some serious flaws. It's not a perfect feature. And the only way that you can truly secure AppLocker and use it in an effective manner is to understand what those flaws and limitations are. So for the first half of the presentation, it may seem as though I'm bashing AppLocker, but please understand that there is a higher purpose here. Okay, so with that out of the way, the first thing I want to do is say what AppLocker is. I'm sure that most of you all listening probably already know what AppLocker is, but for the benefit of anybody who might be new to Windows 7 or Server 2008 R2, AppLocker is nothing more than a collection of group policy settings. And those group policy settings are designed to allow you to control the software that users are and aren't allowed to run in a Windows 7 environment. Okay, now, I realize that software is kind of a vague term. So what does that really mean? Well, in this case, software refers to any executable code. Primarily, this means applications, but it can also mean malware. And in addition to that, Windows 7 also gives you control over whether or not users are allowed to run installation packages. That's the MSI files that so many software vendors use for their installations. And you can also block or allow the use of scripts. Okay, so the next thing that I want to talk about is why your desktops even need to be locked down. Why do you need to go through all of what I'm about to show you? Well, I could probably do the entire presentation on the consequences of not locking down your desktop, but as I've said, we've got a lot of material to cover, so I want to quickly go through a few reasons. For starters, insecure desktops can be a breeding ground for malware. We've all seen situations in which somebody gets an infection by visiting a malicious web page, and then the next thing you know, they've got hundreds of infected files on their computer, and before you know it, those files start spreading to other machines in the organization. If a desktop is completely locked down in the proper manner, then that may not be able to happen. Similarly, unrestricted desktops can be vulnerable to zero-day attacks from malware. Traditionally, antivirus software has worked on signatures. In other words, if a virus comes in, your antivirus software takes a look at this new file and looks to see if it's got a signature that matches that file. If it does, then it classifies the file as a virus. If it doesn't, then it usually leaves the file alone. Now, some antivirus products use heuristics to identify viruses that are previously unknown, but in the real world, I have to tell you that more times than not, heuristics haven't gotten the job done when it really matters. And actually, it's a little off topic, but I tend to think the simple fact that Microsoft offers this feature such as AppLocker is kind of validation that traditional antivirus software may not really be enough anymore to protect Windows PCs against newer threats such as zero-day malware. Another reason why it's really important to lock down desktops is because an organization is legally required to license any software that's running on computers that they own. This obviously includes desktops. So what this means is that if a user comes in and they install a bootleg program on their desktop and you have a software audit in your organization, then you're legally responsible for that bootleg software that's running on the desktop, even if the IT department didn't even know that that software existed. The software auditors have a way of finding that. They can run a desktop inventory, and that's going to show up. So in order to protect yourself against having to license that and having to pay fines for having unlicensed software, it's important that you're able to control what software is actually on your desktops. Now, another consequence of uncontrolled software is that unauthorized software can increase support cost. Let me explain this one a little bit. Let's pretend for a second that I'm a help desk employee in a large corporation. I know that the organization uses a predefined desktop configuration, and then they roll this configuration out to all of the desktops within a given department. I also know that this configuration has been thoroughly tested and that all of the drivers work, all of the applications work, everything's compatible with each other. So I get a call from a user, and they tell me that they're having some sort of problem and ask me if I can take a look at it. When I start looking at this problem, I go in with certain assumptions. Primarily, I'm assuming that the desktop is configured in the manner that it's supposed to be. Most desktops are locked down to the point that users can't go in and monkey around in the control panel. And so I'm assuming that the user hasn't done anything there, but I'm also assuming that they haven't installed any software that can cause these sort of problems. So if the user has installed software and that software has caused something to break, I'm going to waste a lot of time tinkering around with the computer looking for other causes of that problem because I'm under the assumption that that software doesn't exist. Had the desktop been locked down, then the user never would have been able to install that software. The problem never would have occurred in the first place, and the help desk wouldn't have incurred the cost of having to deal with that particular problem. Not necessarily just direct cost, but also the cost of lost productivity resulting from the problem. Now, one last consequence that I want to talk about is that in some particular situations, unauthorized software can greatly impact the duration of the log on and log off process. And it can also impact the amount of time that your backups take to complete. To give you an example of what I mean here, I did a job once for a company that liked to take a very free approach with how their employees were allowed to use their computers. Their philosophy was that the employees worked a lot of hours and their office was basically their home away from home. So they tried to give the employees a lot of leeway in what they would allow them to install on their desktops. So one of the problems that they ran into was that this particular company used roaming profiles. Now, the way that Windows worked back then, and it may still work, I'm not positive, was that whenever a roaming profile is in use, when the user logs on, all of the data from that profile gets copied across the network down to the user's local PC. At the end of the process, when the user goes to log off, everything in the profile gets copied back up to the network in case the user's made any changes. Well, this organization had users who had copied some software, they had entire music collections and everything else within their user profile. So when the users were going to log on or log off of Windows, for some people with a larger profile, the process was taking like 45 minutes. By controlling the software that's on your desktops, you can keep this from happening and keep log in and log off times reasonable. And also help to make sure that you don't suddenly exceed your backup window because somebody loaded up something that you weren't counting on. Okay, so obviously there are some very important reasons why you should lock down your desktops, and these reasons are nothing new. The need for desktop lockdown has been around for a long time. And believe it or not, there have been capabilities for locking down desktops for quite some time now. As a matter of fact, software restriction policies first were introduced with Windows XP way back in 2001. And the software restriction policy mechanism even still exists in Windows 7 today. Software restriction policies, in case you're not familiar with them, are basically just a primitive version of AppLocker that came before AppLocker. But one thing that you need to know about software restriction policies is that if you are using them right now and you transition to Windows 7, Windows 7 isn't automatically going to take your software restriction policies and roll them over to AppLocker. That's because there's some very fundamental differences in the way that the two mechanisms work. And I'm going to get into that a little bit later on. Okay, so if software restriction policies have been around for the better part of a decade, you might be wondering why you don't hear about more people using them. Well, there's several reasons for that. One reason is because software restriction policies can be extremely difficult to implement and to properly maintain. I don't want to spend too much time talking about the anatomy of a software restriction policy because I've got some other things to get into, more specifically AppLocker. But I need to give you a little bit of a background so that you can appreciate some of the things that I'm going to show you later on. Software restriction policies, just like AppLocker, were based on rules. The policies consisted of file rules, hash rules, path rules, certificate rules, and zone rules. And the problem with these rules is that they tended to be really messy and that they were often contradictory. And it also made it really difficult for an organization to maintain their restriction policies. For example, the most secure type of rule was probably either a hash rule or a certificate rule. But let's talk about the hash rule for a moment. A hash rule basically just takes a mathematical hash of an executable file and uses that hash as a way of identifying the file. Well, what happens is that now almost every software company out there routinely releases updates for their applications. Well, when you update an application, if the executable file itself also gets updated as a part of that update, then the hash changes, and that completely invalidates the hash. So that completely undermines hash rules. So if an organization is depending on those hash rules, they have to create new hashes every time they replace executables. Certificate rules are also considered to be one of the more secure types of rules used by software restriction policies, but the big problem with that is that they tended to be blanket type rules. So in other words, if you approved a particular organization to run software, or if you set up an approval to run software from a particular vendor on your PCs in your organization, you basically approve all software from that vendor. The example that I like to use is Apple. A lot of organizations use QuickTime for legitimate business purposes, but Apple also makes iTunes. So if you create a certificate rule allowing software from Apple, then you've essentially just allowed iTunes as well as QuickTime and anything else that Apple happens to make. Path rules referred to rules pertaining to either direct file paths, usually in the program files folder, or registry paths. Again, these have their problems as well. The end result was that a lot of times these rules ended up being completely contradictory to each other unless they were implemented very carefully. And if a power user knew what they were doing, it's pretty simple to get around software restriction policies. Okay, so now that you know a little bit about software restriction policies, I want to turn my attention to AppLocker, which was the main purpose in this presentation. As I said earlier, AppLocker was intended to be a next-generation replacement for software restriction policies. Microsoft, in creating AppLocker, wanted to overcome some of the problems that software restriction policies were so notorious for. Specifically, AppLocker provides a more granular levels of control than software restriction policies ever had, and you're going to see some of that granular control later on in this presentation. Another thing, and this is a biggie, is that with software restriction policies, you created a policy, and that policy had to be applied to either a user or a group. You had to apply the policy as a whole. You couldn't take bits and pieces of it. Well, with AppLocker, Microsoft breaks this down so that now you can assign either or you can assign a whole policy, or you can assign an individual rule. rules can and rule exceptions can be created for either a user or a group. So that's some of the promises of AppLocker, but let's take a look at how things turn out. Actually, before I do that, I need to talk about Microsoft's philosophy behind AppLocker. The main design philosophy that Microsoft uses is that there are nearly an infinite number of applications in the world. And by application, I mean any kind of software that can execute. This could be a legitimate application. It can be malware. It can be whatever. Having said that, there's a finite number of applications that you authorize for use on your own network. And you usually know what those applications are because you're the one who authorizes them. So what AppLocker does is it whitelists the applications that you approve, and it automatically blocks everything else. So having said that, Microsoft has been a little bit overzealous in the way that they have implemented AppLocker. If you think back to the days of Windows 98, Windows XP, that sort of thing, you'll recall that Microsoft used to get bashed all the time about the way that their security was, or rather lack of security. Some people would say that they still aren't secure, but I'm not even going to go there. In response to all that bashing, Microsoft introduced something several years ago called the Secure Computing Initiative. Basically, it was a new philosophy for the company that stated that security is now going to be a priority and that everything's going to be built around security. And I think that it probably comes into play because of that Secure Computing Initiative, that the basic design philosophy behind AppLocker is completely solid, but AppLocker can be a little over-aggressive in the way that it enforces that philosophy. If you take a look at the screen right now, there is an actual dialog box from AppLocker shown at the bottom of the slide. Now, this dialog box says the default rules are not currently in the rule list for this rule collection. When creating rules, it is important that you also create the default rules to ensure that important system files will be allowed to run. Do you want to create the default rules now? So what does this mean? Well, earlier I talked about the way that software restriction policies make use of different types of rules. AppLocker is the same way. It doesn't use all of the same types of rules as software restriction policies do, but it's still rule-based. So basically what happens is that in AppLocker, you create rules, and the rules are designed to allow certain applications to run. Anything that you don't create a rule for is automatically denied. So what this dialog box right here is telling you is that Microsoft allows you to create what they call a default set of rules. These are rules that apply to the Windows operating system. And it's essentially saying that if those default rules aren't created, then the Windows operating system itself may not be allowed to run. And it's asking you, do you want to go ahead and create those default rules so that you can ensure that the operating system continues to function? Pretty scary stuff. Now, I do need to note that I've been all over TechNet and MSDN and some of the other Microsoft sites, and I haven't been able to find anywhere where Microsoft comes right out and says that if you don't enable default rules, then Windows completely locks down on you. But having said that, this dialog box right here and some of the subtle references within some of the TechNet articles that I've read pretty much tell you everything that you need to know. So before I move on, let's go ahead and take a look at another example of aggressive behavior. Now, I'm assuming that everybody here is familiar with group policies. Generally, a group policy is either enabled, disabled, or not configured at all. Enabled means that the group policy is in effect. Disabled means that it's not in effect. And not configured means that you haven't addressed it one way or the other. In the case of AppLocker, you've got a couple of different enforcement modes that apply to these group policies, and you can see these right here. And this is actually clipping straight out of a TechNet article. So what you can see here is that if you enable the group policy, then you've got a mode where it enforces rules. In other words, the rules are turned on and they do what you told them to do. We've got another mode right here called audit only, which I'm going to talk a lot more about later on. Essentially, this means that AppLocker is going to tell you what would have happened had the rule been in effect, but it's not actually going to enforce the rule. So that way, if you've made any mistakes, then they're not going to have to pay for those mistakes. Excuse me. But if you look right up here at the top, you're going to see the really important part. Not configured, which, as I said, usually means the rule's not even in effect. But in this case, here we have a TechNet article saying that this is the default setting. Keep that in mind. And it says that if linked group policy objects contain a different setting, that setting is used. If enforcement is not configured, but rules are present in the corresponding rule collection, those rules are enforced. So in other words, if you go in and you create some AppLocker rules, even if you haven't explicitly told Windows to enforce those rules, they're going to be enforced anyway. When you combine this with the notion that you could potentially lock yourself out of Windows by configuring AppLocker incorrectly, this is pretty scary stuff. So always, when you're creating your initial rule collection and doing your testing, start out with audit mode. It can save you a lot of headaches down the road. Okay, so the way that AppLocker is a little bit over-aggressive can be a bit of a disappointment, but there are some other disappointments that I need to talk about. And this goes back to the whole thing I mentioned at the beginning about that I'm not trying to bash AppLocker just for the sake of Microsoft bashing, that there is a reason why I'm showing you this. Some of these disappointments include the fact that AppLocker rules are only compatible with Windows 7, Ultimate and Enterprise Edition, and Windows Server 2008 R2. Now, in a way, I can't complain too much about this one because AppLocker is a new feature that was introduced in Windows 7 after all, and it kind of makes sense that it wouldn't be retroactive to some of the earlier versions of Windows. Although, even though I haven't heard anything out of Redmond, it wouldn't surprise me a bit if Microsoft eventually releases a Vista Service Pack that adds AppLocker support. You never know what's going to happen down the road. Another disappointment is that AppLocker isn't backward compatible with software restriction policies. As I mentioned earlier, if you have software restriction policies in place prior to rolling out AppLocker, those software restriction policy rules aren't going to automatically migrate over. As a matter of fact, there's not even a way that I know of to manually migrate those. You have to manually create a whole new set of rules in AppLocker. So what happens if you run software restriction policies and AppLocker side by side, you may be wondering. Well, what happens is that any machine that's running Windows XP or Vista is going to continue to support the software restriction policies, and then Windows 7 is going to end up ignoring these software restriction policies and only using the AppLocker rules. Of course, if you haven't enabled AppLocker yet, then Windows 7 is going to use the software restriction policy rules just like XP and Vista will. Another disappointment is that AppLocker doesn't create reports, and this is kind of a biggie for me because in a highly secure environment, you need to know if somebody tries to run an unauthorized application or if you have a malware outbreak that's trying to occur. And there's no centralized reporting mechanism that's going to tell you that. If you need to know this information, you actually have to go to the desktop, open up the event viewer, and look for the events that were generated. Okay, so a few more disappointments that I need to talk about. One thing is that there's no real interaction between AppLocker and your patch management or system management software. Now, that's not to say that you can't use AppLocker in a way that allows you to keep your desktops updated. You can. You can use publisher rules that are blanket rules for specific publishers. For example, if I wanted to automatically approve all updates from Microsoft, I could create a publisher rule that automatically approves anything coming from Microsoft. Of course, I warned you about the danger of blanket publisher rules earlier. But having said that, AppLocker doesn't directly talk to WSUS or any of the other patch management products on the market. Another problem with AppLocker is that if you want to block an application, and the slide says approve an application, it should say block. But if you want to block an application, it's often going to require you to create two separate rules. You're going to need to create a rule to prevent the application from executing, but you're also going to need a separate rule to prevent somebody from being able to install the application. And this has to do with the way that rules are broken down in AppLocker. You're going to see that later on. Finally, and I consider this last one to be sort of the Achilles heel of AppLocker, AppLocker only works if the App ID service is running. And this service doesn't run by default. This is a Windows service, and theoretically, if somebody wanted to get around AppLocker, all they have to do is open up a command prompt window, and if they've got the necessary rights, they can just type net stop enter the name of the App ID service, and boom, they've just shut the service down, and AppLocker is no longer in effect. So just something to keep in mind. Okay, so obviously AppLocker has its benefits, but there are a lot of shortcomings. So this begs the question, should you use AppLocker? Well, my general consensus is that AppLocker works fairly well in small organizations or medium-sized organizations, as long as those organizations aren't overly dynamic. If they use a fairly static set of applications, then AppLocker seems to work relatively well. In a large enterprise class environment, just the sheer number of rules that you have to create because of all of the different desktop configurations and the highly dynamic nature of new applications constantly coming in and new updates and all that, I personally don't really think that AppLocker is practical for those types of situations. You're probably going to be better off with a third-party solution. But that's just my opinion. So, okay, if I was just going to say that you shouldn't use AppLocker, then I might as well end the presentation now. But as I said, there are situations where AppLocker is a viable solution. So if you are going to use AppLocker and you find that it's a good fit for you, then you're probably wondering what types of new things are available in it that differentiate AppLocker from the software restriction policies. Well, as you can see on the slide, AppLocker has several new features. First of all, you have the ability to specify users or groups at the rule level rather than just at the policy level. I talked about that a little bit earlier. Another new feature is the audit-only mode. Again, extremely important. I already talked about this one to a degree, but definitely worth knowing about. Another thing is that you have the wizard for creating the default rules. Microsoft doesn't force you to manually create the rules for every Windows file that's going to have to run. AppLocker can do that for you using a wizard. You have the ability to create a policy, export that policy, and then import that into another machine. This is another really handy new feature and something that I'm going to talk about later when I talk about best practices for AppLocker. You can create rule collections. We also have PowerShell support, so now it's possible to interact with AppLocker through a series of PowerShell commands. And finally, you have a new custom error message feature. What this is, I don't want to go into it too much, but basically you can create a custom error message that pops up on user screens if they try to run something that you're not authorizing. Okay, so now that I've talked about what AppLocker is, what its shortcomings are, what its new features are, I want to get into the best practices for anyone who wants to deploy AppLocker. And these best practices, these are a combination of Microsoft recommendations and some of my own recommendations based on hands-on experience with AppLocker. The first recommendation that I would make is that you should start out by creating a standardized desktop image and then use that image to deploy Windows on a PC. Don't set up a PC in your ideal manner and then start experimenting with AppLocker on it, because I've used AppLocker enough times to know that it's extremely easy to mess up your deployment image. So you're a lot better off just creating an image that you can deploy over and over if you have to, so that way if you keep making mistakes, you don't have to manually reconfigure Windows every time. You've just got a centralized image that you can redeploy each time you need to, until you finally have AppLocker set up in a way that makes sense. Another recommendation that I would make is when you start out with AppLocker, as I said, it's very easy to make a mistake. So start out on your test PC by using local security policies and fine-tune those local security policies until AppLocker is working the way that you want it to. Don't start out by setting up AppLocker rules in Active Directory, because if you make a mistake, that mistake is going to get propagated to every Windows 7 PC that the Active Directory policy applies to, and that could turn out really, really bad if you make a catastrophic mistake. Third recommendation, I've already talked about this quite a bit, but it's so important that I want to emphasize it one more time, is to start out by making sure that AppLocker is running in audit mode, so that way you don't accidentally lock yourself out of a PC. Finally, after you've thoroughly tested all of your rules and you're sure that they're working the way that you want them to, you can use the import-export feature that I mentioned on the previous slide to actually export all of the rules that you've created and then import those into the Active Directory. So that way, you don't have to go back and manually recreate all of the rules that you've established at the Active Directory level. You can just import those rules. Finally, one last thing that I want to mention is that you don't have to completely redo your entire Active Directory to be able to support AppLocker. Windows Server 2003 and Windows Server 2008 domain controllers can host AppLocker policies. But having said that, you're going to need at least one domain controller running Windows Server 2008 R2 for the initial rule import or creation process. And this domain controller is also going to come in handy anytime that you find yourself having to create a new AppLocker rule. Again, I don't recommend creating the new rules directly on the domain controller, but that is a limit that I wanted to at least mention. Okay, so now let's talk about creating an initial rule set. If you look at the right side of the slide, you can see a screen capture from AppLocker. You can see that I'm working within the local security policy. So I'm following my own recommendations here and working off a local system rather than at the group policy level. And we can see AppLocker right here under System Settings, Application Control Policies, AppLocker. And you can see that beneath that we have three different types of rule collections that we can create. We've got executable rules, Windows installer rules, and script rules. So what I've done here is I've right-clicked on the executable rule, and there's a shortcut menu that pops up. Now you'll notice that we have an option here to create the default rules. The default rules are the ones that I mentioned earlier that allow Windows to automatically approve everything that the operating system needs in order to be able to run. But we also have an option up at the very top second from the top, to automatically generate rules. So what does that do? Well, when you automatically generate rules, AppLocker is going to go out and it's going to inventory the machine, and it's going to find out what applications are on it and create rules that will allow those applications to run. So the way that it does this is it tries to create publisher rules wherever it can, and it sets those rules up in such a way that administrators are able to run anything that they want. For an end user, users are able to run anything within the Windows folder, and they're able to run anything within the Program Files folder. Okay, as I mentioned, Windows will try to use publisher rules whenever possible, but sometimes publisher rules won't work because an application might not be signed by the publisher. So in those types of situations, Windows will revert to using a hash rule instead. Now, I mentioned hash rules briefly earlier. Hash rules are based on they use a mathematical hash of an executable file to identify the file. Incidentally, I tend to think that the rules that Windows creates automatically tend to be a little overly permissive. So I tend to think that it's a good idea to go through the rules that once they're created and just kind of take a look at what's actually been approved and make sure that that goes along with your own policies for your organization. A classic example of that is that an end user typically shouldn't be allowed to run the registry editor. But if AppLocker is automatically allowing users to run anything that's a part of Windows, while the registry editor is part of Windows. So that's something that you need to take into account. Okay, as I mentioned earlier, AppLocker rules are the things that are used for authorizing applications that should be able to run on the Windows 7 desktops. And like the software restriction policies, AppLocker does use rules, but it doesn't use the same types of rules as software restriction policies, although there is some overlap. The types of rules that you can create are publisher rules. That's where you look at a executable file's digital signature and look at who published the application. Path rules, file hash rules, and DLL rules. Now, DLL rules are something new to AppLocker, and this is a rule that you can use to allow or disallow DLL files. Windows doesn't allow DLL rules by default because they tend to be extremely resource intensive, and it can also cause some catastrophic side effects if you don't approve the proper DLLs. So Microsoft generally recommends avoiding the use of DLL rules unless you just absolutely need them, and I tend to think that that's a very good idea. So That's one recommendation I would certainly follow. And again, Microsoft's other recommendation is to use publisher rules whenever possible. So why should you use publisher rules whenever you can? Well, it has to do with the granularity of those rules. If I can advance the slide here. Okay, here we go. So what I wanted to show you is just how granular publisher rules are. Now, earlier I mentioned that in the case of software restriction policies that a certificate rule, which was the software restriction policy equivalent to a publisher rule, you could only create blanket rules. And I used the example of creating a rule that allows anything published by Apple to run, but that might allow business applications that are legitimate for business use, such as QuickTime to run, but it would also allow other things such as iTunes to run that you may not necessarily want running in your organization. Well, in AppLocker, you've now got some granularity in place. So if you look at the slide right here, you've got a slide bar that you can use to adjust the amount of enforcement that AppLocker uses for publisher rules. At the least granular level, it works just like software restriction policies. You can specify up to your publisher, and then anything from that publisher will be allowed to run. On the next level of granularity, you can specify a product name. Here on the screenshot, we've got Microsoft Office 2000, but you can specify any application. We can take it down to the file level. You can specify winword.exe, which is part of Microsoft Office. So in this particular case, this would allow Microsoft Word to run, but not necessarily everything within Microsoft Office or everything that Microsoft publishes. Finally, you can specify an AppLocker rule based on file version. And you'll notice that just to the right of that, there's a drop-down list that allows you to specify this version or above. And this can be really handy for situations in which you've just upgraded to a new version of an application and you need to win users off of the previous version. You can go in and you can actually set what version of the application users are allowed to run without having to go in and completely create a new rule in the process. So if publisher rules are so granular and other rule types aren't, why wouldn't you always use publisher rules? Well, as I've already mentioned, not every application is digitally signed. That's pretty much the main reason for not always using publisher rules. Having said that, I should also mention that sometimes publisher rules can give you a false sense of security. There are a couple of things that you need to keep in mind anytime that you're working with publisher rules. First of all, applications that are digitally signed, the digital signature only confirms that the code hasn't been tampered with since the time that it was signed. It's generally accepted within the IT community that if an executable file is digitally signed, that the file is legitimate. But even though this holds true most of the time, it isn't always 100% certain. There have been a few documented cases of situations where somebody has created their own digital signature fraudulently to pass themselves off as another company and basically signed a malicious executable and made it look like that executable came from a trusted source. Now, if you know what you're doing, situations like this are usually pretty easy to spot, but they are out there, so I wanted to at least mention it and just kind of caution you not to let digital signatures lure you into a false sense of security. To let you know that that is something that you need to check out. You need to check out the authenticity of the signature before you start creating AppLocker rules based on that signature. Okay, so the last thing that I want to talk about is maintaining your baseline configuration. I've talked about the initial setup of AppLocker based on a PC that's ideally configured to your standard, but as we all know, PC configurations tend to evolve over time. Software updates come out, new applications get deployed, old applications get phased out. So what do you do to maintain your baseline configuration when you're using AppLocker to lock those machines down? Well, it's important to note up front that you're going to have to create a new AppLocker rule anytime that you install a new application. Remember, AppLocker is designed to automatically deny anything that you haven't specifically approved. So that new rule for any new applications, that's going to be essential unless you happen to have a blanket publisher rule in place that's going to allow things from that publisher to run without creating a new rule. As I mentioned earlier, in some cases you're even going to have to go so far as to create multiple rules. You'll need an executable rule that's going to allow the application to run, but you're also going to need a Windows installer rule that will allow the application to be installed in the first place. And once again, you can create a blanket publisher rule to reduce the administrative burden so that you don't have to go in and create a brand new rule every time you install a new application. But blanket publisher rules also tend to reduce security by potentially allowing applications from that publisher that you might not necessarily have wanted running within your organization. Okay, so finally I want to talk about dealing with software updates. You saw a few minutes ago that you can use publisher rules for version control, and that's really the approach that I would recommend for anything that could potentially be updated. You saw that you can use the and above setting to implement a setting such as allow version 14 and above of a certain application. And that's really a great way to go about dealing with approvals without having to worry about creating a new rule every time a new update comes out. And again, if updates are unsigned, then publisher rules aren't going to work because it's got no way of identifying who the update came from. So in those types of situations, you're generally going to end up having to use a hash rule, and you're going to have to create a brand new hash every time an update comes out. So this is, sadly, one of the limitations with AppLocker. So with that said, I want to thank all of you for tuning into this presentation, and I want to thank everyone at Bit9 for having me, and turn it back over to Carolyn and Tom.
Great. Thanks so much, Brian. And thank you to everyone who's joining us in the audience. We've had some great questions that have come across. I'm just going to take a moment here to pass the ball off to you, Tom.
Thanks, Carolyn. What I'd like to do quickly is just pick up on Brian's discussion and kind of follow up with some questions about if you're looking at AppLocker, you're probably looking at AppLocker for one of three reasons. One, to reduce the cost of your environment. Gartner has metrics that say a poorly managed endpoint costs about $700 more per year. Second is you might have, whether it's license compliance or it's just good practice, best practice, or some external regulation that says you need to control software on the endpoint. Might be PCI, might be HIPAA, might be something within the education community. Or lastly, it might be just good incremental controls on the endpoint to prevent things like a targeted attack or an advanced persistent threat, which we know has hit a lot of companies as of lately. So that's probably the driver for looking at AppLocker. And then you say, okay, based on what Brian's described, I think two questions come to mind. Well, the first one is the upper level question is, does AppLocker go far enough? And what does far enough mean? Is it manageable? And the second, is it effective? So I think when you think about manageability, what comes to mind is, do you think that potentially deploying a kind of default deny-only policy, Brian obviously gave us advice not to put it in audit mode first, but even when you transition from audit to kind of a full block mode, it sounds to me like if you deploy this in a dynamic environment, you'd probably end up blocking some legitimate applications, creating help desk calls, and maybe having your IT staff run around a little bit. Secondly, I think when you have to create hashes to put those hashes on an approved list, that's labor intensive, and so I think we have to question that. And then also, if there's limited centralized reporting and visibility across the environment, I think that's something we should take a close look at as well. So that's the manageability aspect. Then from an effective standpoint, can you look at all the files, not just DLLs or ActiveX controls? Can you look at batch files? Can you look at EXEs, the gamut of things that have executable code? If you're looking at AppLocker from a security perspective, you need to see everything, not just a subset of what can execute. The other thing that I think that sometimes isn't, when you think about AppLocker, you think about user controls, kind of what can I do to ensure a user doesn't run applications or install software? But there's a lot of applications that will try to take advantage or exploit an existing system where a user is not logged in. Just go after Windows services, for example, DLLs that exist. So, again, that's kind of a blind spot for AppLocker. Brian talked about a best practice of going out and looking at building an image, starting from a fresh image. Well, in a lot of cases, while that, in a best practice perspective, absolutely makes sense, but from a reality perspective, when you think about taking and Windows 7, it might make sense because Windows 7 might be new. But what if you go back to XP? What if you go back to other systems, operating systems? It's hard to go back and get a user back to a base image. They're already running. They're already deployed. In a way, their desktops are already polluted with all kinds of software. So how do you ensure you're not going to harden a corrupt system? If Windows 7 is running and you then decide to turn on AppLocker later, what about all the software that's out there that's running? How do you ensure that's trusted? And obviously, I just mentioned this as well, but Windows 7 has AppLocker and the previous versions don't. If you're all Windows 7, then, it's kind of, this is not an issue, but I find it more and more there's a mix within the environment. So these are some of the things to consider when you think about AppLocker for sure. So next, how can Bit9 help? So we talked about what you're trying to do, whether it's operations, reduce cost, or it's compliance or security. And then we talked about some of what I would consider Brian emphasized, and I'm going to emphasize as well, limitations, whether it's manageability or its effectiveness. So how can Bit9 help? Well, the first thing is Bit9 has a solution that has been in kind of in the same space, application control, application whitelisting, now since 2002. And we've built an automatic whitelist builder. What that means is that we're going to tell you what software you can trust. Software pushed out by SCCM is automatically approved. Software that is published by Microsoft is automatically approved. Software that resides in your /library directory is automatically approved. So the burden of building hashes and creating hashes and managing hashes has all been automated with Bit9. The second thing is when you deploy on an environment, a lot of times, again, desktops have been running for a while. We have the ability to assess the trustworthiness of the software that exists on the machine, not just the software that's going to be installed, but the software after the control is put in place. But what about the 15,000 executables that exist on a machine? How are you going to ensure that software itself is something you can trust? We can help there. Think about it as well as the new software. New software comes on the endpoint. We do have an audit policy as well, kind of a visibility-only mode, and we have different modes for what to do when new executable code hits the endpoint. And we're looking at all executable code, not just EXEs, DLLs. Again, just run the gamut across all code that has execution within it. We're not just looking at user login time and impacting the user's ability to run software or install software. We're looking at boot time. The minute something starts, the machine boots up, any new files that get introduced. It might be, this is where a rootkit might get introduced or start to boot into rootkit. So again, not just a user space, but also at system space as well. Bit9 has been architected to manage 50,000 computers from a single management console. So Brian talked a lot about scalability and manageability. Bit9 has addressed that concern. And then lastly, when you think about kind of the concept of looking at Windows computers, we did talk about the platforms, but we started as a company looking at applications. And then we added the concept of looking at portable storage devices, controlling access and non-access to devices. We've added recently the ability to control access and visibility to registry settings, configuration files, and also memory, user memory, process injection. So we go well beyond just looking at applications at this point. We're relating it to AppLocker because AppLocker is application specific, but just a reminder that when you think about Bit9's ability to control and whitelist, for example, applications, you can whitelist portable storage devices, you can control who can change a registry setting, you can control who can change a file, maybe it's a log file, maybe it's a configuration file, but ultimately who has access to those files. And also you can protect processes that maybe might get injected into memory, and we can harden a process, so only the right activities are taking place in the memory space for a process. The solution itself is Bit9 Parity Suite, and Bit9 has a global software registry that is leveraged as well. Bit9 Parity Suite consists of three components. The first is parity visibility. Think of it as complete visibility of all software on all systems at all times. Real-time visibility, and really think of it as the ability to detect new threats or new software being introduced to the environment. Second is parity knowledge. Parity knowledge is the interface that goes into the global software registry. It assigns a reputation to every piece of software we find in your environment. The software that exists, that's been there for years, or the software that is being introduced to the environment as well in real time. The last is parity control. This is where you start to implement what can and cannot run. We integrate with Windows Active Directory to pull in users, groups, computers, OUs, and we assign policy as to how to handle what they can run, what they can't run. We also have the ability to ban software. We'll talk about that in a second. It all leverages the Global Software Registry. Think of it as the world's largest database of software. When you hire an employee, you might do a background check. This is the equivalent of when you have new software entering your environment or new software that exists. What you can do is do a background check by running the hash against the Global Software Registry. The Global Software Registry then returns a trust factor and a threat level about the software running in your environment. That software, the database, the Global Software Registry, is also available for free with a utility called File Advisor. FileAdvisor.bit9.com is a right-click utility to help identify software on your endpoint. It does do it a single file at a time, but as you can imagine, Parity, the product, leverages that Global Software Registry and looks up all your files all at once, then allows you to get reputation assigned to all your software. The question that we always get is, how do I build and maintain my whitelist? Well, I want to start to kind of relate to existing things that you do today. Think of your whitelist policies, or the way you push out software today is software distribution, Windows Software Update Service. It might be you allow users to download from a certain path or directory. So when you think about the concept of whitelist, think of it as the places that people get software today, the sources they get software today. When you think about a blacklist, you might run, obviously, antivirus products. You might have taken away AV. You might run a HIP-based technology that looks for bad behavior, like talking to an IP address you don't recognize. Well, all these techniques are pretty much a way of ensuring that you can prevent bad software from getting on the endpoint. The first thing people do when they run our software and they get a live inventory is they see Skype. They'll see that, maybe a hash they don't like, or they'll see a keylogger, and they'll ban that. Then they've gotten back the information from the Global Software Registry to help identify that software. Then what they start to do is they say, okay, what other ways does software get on the endpoint? And they assign trusted users. These are help desk users that go out, might install software remotely or walk up to a desktop. They look at publishers. They look at the digital certificate and say, I trust this publisher just like AppLocker. They look at directories, and this is the sources of trusted software. It could be a distribution point for SMS or SCCM. It could be a library. It could be, again, WSS repository. And then self-updating software. There's a lot of Adobe software. Cisco has VPNs. Symantec has the AV products, SEP11 type products, where software does continually update. And we have to ensure all these updates take place automatically. At the end of the day, though, when you think about what's on your whitelist, what's on your blacklist, you're still going to have new software that hits your endpoint, and you don't necessarily know what it is. Well, that software, when it hits the endpoint, you can define policies, varying policies, as to how you want the endpoint to react when a new piece of software hits the endpoint that is not on the whitelist and not on the blacklist. The first is kind of an audit mode. Just tell me if something new is introduced to the environment. Execution is allowed. It's a monitor, kind of a passive policy, but IT is notified something new entered the environment. The second is you can ask the end user for permission, which says, put up a screen that says, do you know something's trying to install? This is a nice way of introducing friction between, for example, a website and a payload that's trying to drop. This would pop up the screen saying, do you want this to install on your endpoint? And then lastly, you don't know what it is, not on your blacklist, not on your whitelist. We can, in essence, put it on the blacklist by saying a default deny policy, ensure that it doesn't run unless it's explicitly trusted. So there's varying modes of what to do with software when it hits your endpoint and you don't know what it is. Well, if it is a questionable file, what we can also do, because we are hashing every single file that hits the endpoint that's executable, we send that back to the Parity server, and all endpoints do this when the product is first installed. That software then is the hash itself, not the software, but the hash is sent up to Bit9's global software registry where we run different AV scanners against our registry. We store the results with the hashes. When the hashes go up, we do a match. We send you back metadata about the file itself. Did it pass the scanners? Who's the publisher? How many people have that file? How old? How long has it been in the wild? And sometimes a category such as that's a keylogger. That's a potentially instant messenger program. That might be a peer-to-peer communication application. So we'll send you back that information. So when there are gaps of knowledge about what software is, again, you have on average 15,000 executables on an endpoint, what we would do is basically give you intelligence background check on that software so you can make an intelligent decision about whether or not to trust it. So when you think about the parity server defines the policies, it pulls in Active Directory, pulls in your logic of what you want to run and not run. When new software hits your endpoint, whether it comes from FTP, device, from Facebook, websites, it might be something to do with BlackBerry software, it might be instant messenger, it might be just directly off the web, or it might be through email. Bottom line is, if it's questionable, if it's not something we recognize and you're a default deny policy, it doesn't run. And what we do is the way we first check it is we say, is it from a trusted publisher? Is it being installed by a trusted user? Did this come from a trusted directory? Or is this a self-updating application? If it meets your trust criteria, it's allowed to install. If it doesn't, execution is blocked. So what that means is that, this could be unauthorized, it could be unlicensed. We like to think of it as something that potentially is malicious, so a botnet rootkit, spoof AV, targeted attack. If trust is not established, if it doesn't meet your trust criteria, it doesn't run. Obviously, a great way to control configuration drift, compliance regulations, and obviously security across the endpoint. Another use of the product is, some people say, well, you know what, I just want to know. I don't necessarily want to control and stop all the software. Just tell me when machines drift or when they introduce risk. So you can build a baseline of trusted software by taking a snapshot of an existing system and say, I trust this system. This is what I would consider a baseline of trusted software. Or it could be a directory of software. It could be multiple systems. It basically is you outline a set of approved software. And then what you do is you identify machines that have new software introduced on top of that have introduced drift. And second, because we have the ability to assess risk and trust to software, you can identify software that's been added to your systems. Again, not controlled, just visibility across your environment. When you come in each day, let's say you have 10,000 computers. You don't know which one to look at first, or you don't know what's been added. We'll tell you all the software, again, without controlling it, that's been added on the previous day. We'll tell you there's been 13 applications added. We'll tell you if it's within your baseline of trusted software or not. And lastly, we'll assess what's the riskiest software that was installed in the last 24 hours on your system with a graphical representation that looks something like this to say, here's the machines that have drifted, here's the software that's been installed, and assign a trust or a threat rating to the software so you get a sense of where to prioritize across your whole environment. Again, this could be 50,000 computers, or it could be a group such as marketing or sales, or it could be ATMs or kiosks. It could be a wide variety. So when you think about what Bit9 can do above AppLocker, it goes well beyond looking at apps, devices, registry, memory, files, well beyond just applications. The ability to centrally manage that across 50,000 computers, define policies, see what's new, assign a trust and a threat rating to all the new software that's been installed using the global software registry. And on top of that, it can be used passively. It doesn't have to necessarily be controls. It could be used in a visibility-only mode and still have tremendous value about what's running in your environment. If it's a security driver you're looking at, obviously we don't need predefined knowledge of what's going to happen to your environment. We can just say, here's what's allowed to run. Don't let anything that's not allowed to run in that environment, default deny. At the same time, ensure you don't get a lot of help desk calls because we have the ability to automatically whitelist software. If it's compliance that's driving it, obviously we could show you drift or we could prevent the drift and you can demonstrate controls for your compliance regulations. If you're trying to reduce help desk calls or re-imaging systems or the drift that just causes performance degradation or endpoints to go down, or sometimes it's called Windows rot, we'll prevent the Windows rot by preventing unauthorized software from running on those systems. Next steps, so you've heard Brian's view on AppLocker, a lot of movement in the right direction, but I think we both conclude that it falls a little bit short for an enterprise. Bit9 has, again, kind of addressed this problem for a long period of time, way back beyond Windows 7, and put in a lot of the scalability, the manageability, the effectiveness that's needed to run in an enterprise. So if you wanted to do more research, first thing we would recommend is Brian's written a white paper for us comparing Bit9 parity and AppLocker. So you have that. That's on the resources page. Second is something more specific to Bit9. There's a data sheet out there about what does Bit9 parity do. Help me understand in more detail. Third is understand how it's used. There's a case study out there how the U.S. military has used this to defend their endpoints. And then lastly, if you want to understand the players in the space, Bit9 parity was given the best rating a software product has ever been given by InfoWorld in the security space. And it also compares Bit9 to other products, but also even to AppLocker. AppLocker kind of didn't make the big picture, but there was a quick comparison about how AppLocker does try to address some of these needs. So with that, I'm going to close on this slide basically saying that there's a lot of information on our website, and if you want a copy of the slides, please send an email to contact@bit9.com. So Carolyn, I think that you have potentially some questions out there for us before we close.
Yes, absolutely. And I want to thank everybody for their time today. Obviously, this is a broad topic, and we've gotten a number of different questions. Brian, if you're available, I've got a couple questions that came in during your presentation that I'll direct to you. But before I do want to pose a question to you, Tom, that's come up in a couple of different forms about the recently announced Microsoft DLL, the hijacking DLL issues that are being reported. How does Bit9 parity handle something like that?
Okay. So we talked about how we have complete visibility into every single system. Whenever a new file is introduced, we hash the file in real time before it's allowed to install or execute. That file, because if someone tries to hijack or compromise an existing DLL, what that means is that they're changing the file. They're changing or introducing a new file. What that means to us from Bit9 is that the new file, if you're in a default deny policy where only approved software is allowed to run, someone introduces a new DLL or tries to compromise an existing DLL, what happens is a new hash is created. Because you're in a default deny policy, that new hash, it's not something that we trust. It's not from a publisher. It's not from a directory. The hash doesn't match something that we said should run in the machine. Therefore, because it doesn't match our trust criteria, if someone tried to compromise a system, we would not allow that new hash to execute or run. Therefore, your system would not get compromised.
Great, thank you. Brian, if you're up for it, I've got a couple of questions that came in through the course of your presentation.
Yeah, sure. Can I make one quick point first, please?
Sure, please do.
A couple of times during his presentation, Tom mentioned that compliance was one of the primary driving forces behind people looking at desktop lockdowns. I didn't mention compliance when I was talking about all of the reasons for locking down a desktop, but one thing that I did want to mention is that in smaller environments, you may very well be able to use AppLocker to achieve the necessary compliance, but the problem with that is that AppLocker doesn't really have very good reporting mechanisms, arguably almost none. So the burden of being able to prove that you're compliant could get a little sketchy.
That's a great point, actually. I think some of those limited to zero reporting is mentioned in the InfoWorld comparison that Roger Grimes wrote that Tom was talking about a slide ago. The question actually was about some of what you talked about in terms of an administrator being accidentally locked out of Windows 7. Can this really happen if they forget to create default rules, Brian?
Honestly, I don't know. I've never seen it happen before in the real world, and I've never, even though I've looked for it extensively, I've never seen anything on TechNet or MSDN that comes right out and says, yes, you can be locked out. But if you read between the lines, Microsoft provides numerous hints that, yes, that is the case. And you saw the dialog box during the presentation that pretty much says it all.
Yeah, absolutely. What about a situation where a user cannot use publisher rules? What are their options with AppLocker? What should they be using?
Well, AppLocker has several different types of rules that you can create, but if the situation at hand means that you can't use publisher rules, then you're best off using hash rules because those tend to be more secure than some of the other rule types that are available to you.
Okay, great. Tom, there's another question for you that was about when you were talking about in the course of preparing or running your Windows 7 migration, what did you mean by don't harden an infected system?
Well, if you're using AppLocker, for example, when you install AppLocker in a system, or turn it on, I guess, bottom line is that it's going to kind of take the software that is being installed and moving forward and address that software. It does not have kind of a retro, what about the software existing on the endpoint. So when you turn it on post, the system's been running, so let's say for a month or two, you've lost control because you've already got software on the endpoint, you don't know what it is, and you can't necessarily stop it from getting there. With Bit9, when you think about when we install, we hash every file on the endpoint and then run that against the global software registry to give you that trust, that level of trust and confidence about the software that's running. For example, if someone's system, Bit9 was installed on a system that had the recent compromised DLL installed on it, we would identify that file and say that we don't recognize this file as something that we trust. It may not be something we identify as malicious, because we may not have known about it. It might be 0-day. The AV vendors didn't necessarily label it as malicious just yet, but we would identify it as drift, something we don't trust, and highlight that and bubble that within the list of new files being added to your system, and that would give you a sense for, even after the fact, that something that is unauthorized is running in that system. So you need that retro look back on systems, and that GSR, the ability to do the background check on the software, gives you that ability to get a confidence level for the software that exists on systems when you enable a control.
Great, thank you. Well, in looking at the clock, we do need to sign off, but I want to encourage everyone who still has questions to send them to us using that chat and Q&A window. Many of you sent questions over that we did not have a chance to get to live during the event today, but we will have a Bit9 representative follow up with you afterwards to make sure you have the information that you're looking for. Brian Posey, terrific presentation, and thank you for your time today. Tom, we really appreciate you coming online, and to everyone in the audience, have a great afternoon.